Hello beautiful people and welcome. In today's video we are going through the Chapter 8 exam for the Integrated Math 1. As always, I am human. If I make a mistake, please let me know where the mistake occurs. In question 1, it is asking you to find the lengths indicated. You must show your setup and your work for credit. So what I mean by setup is I want you to create your segment addition postulate. So you're going to take your finger, you're going to put it between two letters. So I have D. Oh, looks like my pencil might not be working in the beginning. Let's go ahead and change that. We have DE plus, put your finger between the next two letters, EF, and then that's going to equal your total big piece of DF. After that, then you have your work, which is substituting or replacing with information that you have. So we have DE is 4. EF is unknown, so we keep it as EF, and DF we do know is 10. After that, you're going to continue working on your equation by creating a dotted line. You're going to subtract 4 both sides, creating EF left over here. 10 minus 4 is 6, so EF is equal to 6. For the second one, it looks like we have different segments. So look at this one here on A. Notice that we have just 2 pieces of information versus here we have 1, 2, 3 pieces of information. Your setup is going to be important. Now, because there are multiple sections, we can create different setups. So the setup for this one, I don't need to see all of them. In class, we've done up to 5 different setups. I just need the ones that would work. So with this one, we're taking a look and we're noticing that HI is missing. I do know what IK is, and I know what the total piece is. So my correct first setup is going to be HI plus IK. So I'm skipping J. J right now doesn't exist for me. And then that's equal to the total piece of HK. HI is unknown, so we keep it as HI. IK is known at 12. HK is known at 16. Dotted line. Subtract 12, subtract 12. HI is 16 minus 12, which is 4. And it does look like I did create a typo. This should say an HI. It looks like I put 2 HJ. So let's create this first one as an HI to fix my typo. So HI is 4. So I'm going to place that 4 here. Now that we know HI, I can continue with a different setup in order to find what H, that's not an H, that's a J, JK is. So I can do my total addition segment postulate. So HI plus IJ plus JK is equal to HK. So this is our initial setup. HI is 4, IJ is 9, JK is unknown, so we keep it as JK, and HK was 16. With this one, you do need a little bit more work because you do need to combine like terms of 9 plus 4, which is 13. Bring down the JK, bring down the 16. Then we can subtract 16 both sides, 13 both sides. We can subtract 13 both sides. Bring down the JK, 13's eliminate here, subtract out. 16 minus 13 is 3. Bring that up here. Now they are asking us also for HJ. So HJ is right, oops, I went too far, is right here. So we want to know what the distance is between H and J, and we can see that we're going through 4 and 9. So HJ is 4 plus 9, which is 13. Okay, next one, C. This one is asking you to solve for x. So again, we want to create our initial setup. Our setup is our letters, so HG plus GF is equal to HF. HG is negative 4 plus 2x. GF is x minus 2. HF is 15. Now this one is asking you to solve for x, so we're going to drop the parentheses. We don't need them. We are going to combine like terms first on one side. So things like a negative 4 and a negative 2, the x's, so we have a negative 4, 5, 6 plus 3x. Bring down the 15. I'm going to add 6 to both sides. I am running a little bit out of space, so I'm going to kind of shift it over. 15 plus 6 is 21. Divide by 3, divide by 3. X is then equal to 7. Now reminder, your measurements cannot be negative, but x can be negative. So if you get a negative here, that's okay. But if you get a negative here, that's incorrect. Again, so measurements cannot be negative, x's can be negative. Okay, moving on. Next one is asking once again for us to solve for x, then solve for QS. So we do have multiple setups. We want to create the setup that will be most beneficial. Again, in class, we did about 5 different setups. We don't need to do 5 different setups here. We need to choose the one that's going to be beneficial. So for me, I am going to choose, there's going to be many unknowns, so I have to be careful. Let's see what I can do. So I think I'm going to choose here, if I skip Q and do PR plus RS is equal to PS. I'm going to choose PR. We have PR as 24 plus RS, which we don't have, but we do have the entire PS at 25. This setup will create, subtracting 24. I cannot do anything with RS. This is an unknown. This will create RS for us and give us that value. Bring down RS. And I get RS as 1. Now it's not asking us for RS, it's asking us for QS, and that's okay. Because if we take a look, we're going to need to do another setup. QS is given to us as 2x minus 1, but QS is RQ plus RS. So let's do another setup. QR plus RS is equal to QS. Now this setup is skipping the first initial section. We technically are not even using P in our setups. QR is x plus 5. RS we determined is 1. And QS is 2x minus 1. Again, drop your parentheses. We're going to need to combine like terms first on one side. So we get x plus 6. Just keep bringing down the 2x minus 1. Then we need to move the x's to one side, so I'm going to subtract x here. Bring down your positive 6, dotted line. 2x minus x is just 1x. You can just write an x, or you can write 1x. It's up to you. Subtracting 1 still there. I'm going to add 1 now. So we get x is equal to 7. Now again, what is it asking us? It's asking us for QS. So we got a third quick little setup here. QS is equal to 2x minus 1. So that means now we're going to put in our x of 7. So in our calculators, we're going to now type in exactly what we see. 2 open 7 minus 1. And I get QS as 13. Remember, x can be negative, measurements cannot. So if this ends up x being negative, that's okay, but the measurement cannot be negative. Moving on, next one, it is asking us to simplify radicals, and it is asking us for exact answers only. What that means is we cannot do any sort of decimals. Okay, if you are typing anything into the calculator that gives you a decimal, that means you are doing something wrong. First thing you're going to do is you're going to recall your perfect squares, and I'm going to type in the number that I see. Let me shift this. So I see a 32, I type in the 32. And I'm going to divide that by the closest perfect square, and that's 25. If it gives us a decimal, it is incorrect. It doesn't work. So next, this is 5 times 5. So in my brain, I'm doing 4 times 4, which is 16. And 16 does work. So I'm going to split this out. So we have 2 arrows, 2 houses. So 2 arrows and 2 radicals for our houses. The first one is always what you type in. The second one is always what the calculator gives you. So I typed in 16. The calculator gave me 2. Square root of 16 we know is 4. Bring down the square root of 2, and this is your simplified answer. The next one, 8. Again, type in 8. Closest square root, perfect square, not square root, but closest perfect square to that is 9 is too big, so 4, and that 4 does work. 2 arrows, 2 houses. Square root of 4 is 2. Bring down the root 2, and we have our answer. 72. Okay, let's type in 72. Divided by, closest perfect square is 8 times 8 is 64. That doesn't work. 7 times 7 is 49. Nope. 6 times 6 is 36, and 36 does work. Okay, you want to be careful with certain numbers. You want to always work down, not up on your perfect square. So do not start with 4, 9, 16. Always start with the largest perfect square and then work your way down. So 2 arrows, 2 houses. Number I typed in was 36. Number the calculator gave me was 2. Square root of 36 is 6. Bring down the square root of 2, and we have our answer. Now, things like the square root of 100, you don't actually use a calculator. This is a perfect square, so this is just something you have to have memorized. The square root of 100 is 10. Find the distance between 6, negative 3 and 0, 5. This is where you need to have your distance formula memorized. Distance is equal to the really big square root. We have 2 parentheses separated by addition. Each of these parentheses is squared with a minus in the middle. Now our formula is x1, let's do x2 minus x1, y2 minus y1. This formula you have to have memorized. If you don't know your formula, you won't be able to do any of these problems. So let's go ahead. D is equal to the square root. Now notice I didn't give you too much space, so you do have to kind of write small. Have your parentheses. And all I'm doing right now is I'm copying down the formula, okay? Now that we copy down the formula, I'm going to go back and I'm going to label my points. You always want to label your points as x1, y1, x2, y2. That will never change. After that, you're going to input your values into your formula in the correct location. So the first number I have is x2. x2 is 0. Then I have x1. x1 is 6. Then I have y2. y2 is 5. Then I have y1. y1 is a negative 3. Careful here with double negatives. Once you write in your values, the next step is you're going to type this into the calculator, only the inside without the radical. So immediately, without even touching my calculator, I know that my next step is still going to have that square root. So I'm going to pick up my calculator, open 0 minus 6, close it, square it, plus open 5 minus negative 3, close it, square it. I'm going to press a enter. This gives me the square root of 100. And we actually just did that question here. Square root of 100 is 10. Again, when you're simplifying perfect squares like square root of 100, square root of 64, square root of 81, square root of 16, you don't actually do your 2 houses, 2 arrows. Instead, you just write the number that is the answer. Let's try again. First step with distance. Again, keyword here is distance. We write out our distance formula, have our parentheses, square them, add them, put a minus. Next, you're going to go in and label your points just like we did in question number 3, x1, y1, x2, y2. Then we're going to put in our numbers in the correct locations. x2 is 5, x1 is 4, y2 is 1, y1 is a negative 9. Again, be careful with those double negatives. Everything that is inside the radical is going to be typed into the calculator. Again, recall what we did in the previous example. Immediately write your square root. Square root will not go away just because you're using a calculator. It's still there. So open 5 minus 4, close it, square it, plus open 1 minus negative 9, close it, square it, equals, and I get 101. So this 101 needs to be simplified. So we're going to type in 101. Now the closest perfect square to 101 is 100. That doesn't work, so that's 10 times 10, 9 times 9. That doesn't work. 8 times 8. That doesn't work. 7 times 7. That doesn't work. 6 times 6. That doesn't work. 5 times 5. That doesn't work. 4 times 4. That doesn't work. 3 times 3. Excuse me. 3 times 3. Oops, that's 96. That's wrong. 3 times 3. Nope. 2 times 2. Nope. And 1 times 1 and 1. So when you get something like this and you have two arrows, two houses, what did I type in? A 1 and itself. This right here, you're not actually going to write as your answer. We're going to cross that out. That means it cannot be simplified. So that means we're going to go back up to where we wrote our square root and identify that is our answer. And that is because it cannot be simplified. If you can simplify, you must simplify. Next question is asking us to find the midpoint. So midpoint has its own formula. Capital M is equal to, now we got big parentheses, comma in the middle. We got two big fractions with both having denominators on the bottom. You're going to open up more parentheses, and each of these parentheses have addition. And the setup for this is going to be x1 plus x2, y1 plus y2. Just like with distance, our first step is to write out that formula, copy it down, big parentheses, comma, denominator of 2, open, open, plus, and close them. Next, we're going to go back to our points and label our points exactly how we've been doing for distance, x1, y1, x2, y2. We're going to put in our points, but make sure you're following your formula. X1 is negative 2, x2 is 9, y1 is 2, y2 is a negative 2. Now when you are doing this, you're actually going to split this up into two sections. Section 1 is going to be the first fraction here. Section 2 is going to be our second fraction here. You're going to type this in separately on the calculator. Yes, parentheses are required. If you don't write in your parentheses, it would be giving you something that's incorrect. So open, negative 2 plus 9, close it, divided by 2, and that gives you a decimal. Remember, decimals are not allowed. So we're going to check if our calculator can simplify this fraction for us. Second, PRB, and this gives us 3.5. Now, remember in my class, mixed numbers are not allowed. I am going to keep that as 3.5 right now, and then I'm going to change that to an improper fraction. Let's do the next one. 2 plus negative 2, close it, divided by 2, equals, well, that's 0. 0 is lovely. So that means we have to convert this 3.5. Since we have a denominator of 2, I'm going to keep that denominator of 2. We're going to multiply 2 times 3, add the 1. So that means that we have our fraction, our midpoint, is 6 plus 1 is 7 halves, comma, bring down the 0, and that is our answer. Again, decimals are not allowed, mixed numbers are not allowed. We only want improper fractions here. All right, let's move on. Next one, it is asking for, given one endpoint and the midpoint, find the other endpoint. Okay, be careful here. We may need a little bit extra space on this one. Well, let's just see. I don't know if I gave you enough space. So we're going to start off with our formula for the midpoint. Again, open, open, comma, 2, 2. I'm going to put in, maybe I should have given myself extra space inside my formula, but that's okay. Be careful here because they are not giving you both x1 and x2. They are giving you the midpoint. Since they've given you the midpoint, you're going to take that midpoint and you're going to plug it into the actual m that you have. So for my m, I'm just going to write in that 5, comma, negative 10. Let me see if that shows up on the camera a little bit. Okay, next I am going to write in my endpoint of x1, y1. So x1 is 9, y1 is negative 3. And you'll notice you end up having these two little sections that are blank. There's nothing inside them. Those sections are your x2 and y2 sections. And what you're going to do is you're going to set two equations based off of the midpoint. So in the first section, you are going to take the first number, 5, and the first fraction, and you're going to set them as an equation. I'll show you what that looks like here in just a few moments. Next, you're going to take the second fraction and the second number, the y value, and you're going to set that as a equation. So for the first one, we are going to have 5 is equal to 9 plus x divided by 2. I'm going to separate this. And for the second one, we have negative 10 is equal to negative 3 plus y divided by 2. Now notice how I wrote these equations. I did not write x2 and I did not write y2. I only put x, I only put y. Second, I do not have parentheses in my numerator. The parentheses went away. And here we're just going to continue and solve for x and solve for y. Starting off, we're going to do a dotted line. We're going to multiply by 2. When you multiply by 2, make sure this 2 is on top, not on the bottom. We have 10, dotted line, 9 plus x, subtract x, don't divide, subtract. X is equal to 1, and put this in a thinking bubble because this is not your answer. Here we're going to multiply by 2, again on top, multiply by 2 on top. We get a negative 20. Adding 3, adding 3. Careful here with the negatives. Y is then equal to negative 20 plus 3, which is a negative 17. Again, dotted, or excuse me, thinking bubble because this is not our answer. Our answer is going to be combined into a point. Our x value is 1, our y value was negative 17. This is our answer for question number 6. Question number 7 is asking us to find IJD if the measurement of DJK is 26 degrees and the measurement of IJK is 78. This is using your angle addition postulate. So we want our setup for the angle addition postulate. We have the measurement of our little angle plus our little angle equals our big angle. So the measurement of angle IJD, remember our vertex has to be in the middle, plus the measurement of KJD equals our big one. Oops, I forgot our measurement. Let me go back just a few seconds. Make sure you have the measurement. Measurement of angle DJK. And again, I switched K and D originally. It doesn't matter. As long as J is in the middle, you can say KJD or DJK. It means the same thing. The measurement of angle, what do we want to call this? IJK. And then you're going to fill in the given information. So IJD IJD is unknown, so we're just going to copy that. The measurement of angle IJD plus the measurement of DJK, DJK is 26 degrees, equals the measurement of IJK is 78 degrees. So this right here is your setup. We want the setup. After that, you're going to subtract 26. Now here our answers cannot be negative because we are talking about an angle measurement. And 78 minus 26 is 52. Now here you have to have degrees. If you don't have degrees, it would be marked as incorrect or incomplete because angle measures all have a degree. Next one, find x. So this, when they're asking for x, x's can be negative, but let's go ahead and mark this up. The measurement of RSN, this guy right here, is 3x plus 6. The measurement of RST, so the whole angle is 161. And the measurement of NST, this little guy, this bigger guy, right, is 28x. So let's go ahead and create our setup. The measurement of angle RSN plus the measurement of angle NST is equal to the measurement of the entire angle of RST. That is our setup. Then we plug information in. RSN is 3x plus 6. The measurement of NST is 28x. And the measurement of RST is 161 degrees. Drop your parentheses, start combining like terms. Here we have 28x that we need to combine with 3x. 28 plus 3, we get 31x plus 6. Subtract 6 both sides. We get 31 times x is equal to 161 minus 6, which is 155. Running out of space, I'm going to shift it up here. 31 times x is equal to 155. Divide by 31, divide by 31. X is then equal to, and I get 5. And it is just asking us to solve for x, so I'm going to put that x in a box. This one here is saying A, name the angle relationship, then solve for x. So we are looking at what angles we have. We have an angle here and we have an angle here. These two angles are a linear pair. Linear because they form a line, pair because there's two of them. Now, what does it mean to be a linear pair? It means that they are supplementary. What does it mean to be supplementary? That means they add to 180 degrees. So when we're doing our setup, we got 6x plus 2 plus 4x plus 8 is equal to 180 degrees. Then we can just continue to solve, drop the parentheses, combine like terms, and solve for x. Dotted line. We got 6x, 4x, that's 10x. We got 2 plus 8, that is also 10. Subtract 10, subtract 10. We get 10 times x is equal to 170. Running out of space, I'm going to shift it off to the side a little bit. We got 10 times x is equal to 170. Divide by 10, divide by 10. X is equal to 17. Moving on to the next one, it is asking what the angle relationship is. So we're looking between this angle and this angle. And the hint on this one is that they are giving you this little box. This little box is between our two angles. So that means this is a complementary angle. Complementary means they add to 90 degrees. So for this one, that was a linear pair. Linear pairs add up to 180 degrees. Why? Well, because they're supplementary. Complementary angles are actually adding up to 90 degrees. So when we set up our equation, x plus 6 plus 63, we're setting it equal to 90 degrees because of this little box. Drop your parentheses. Combine like terms on one side first. 63 plus 6 is 69. Subtract 69. 90 minus 69 is 21. So things like supplementary, linear pair, vertical angles, all of that you need to have memorized. Okay, let's go ahead and move on. Take a look at what they are giving us. They are giving us this angle here and this angle here. And we want to see what the relationship is between them. Because they are directly across from each other, these are called vertical angles. Now, what does it mean to be a vertical angle? Vertical angles are congruent. What does it mean to be congruent? It means equal in measure. Now, since they are equal in measure, you're going to set them equal to each other. 6x plus 4 is equal to 64. Dotted line, subtract 4, and we're pretty much done. Vertical angles are congruent angles. They are equal to each other, so we are going to set them equal to each other and solve. Bring down the 6 times x. Divide by 6, divide by 6. X is then equal to 10. Okay. And that wraps up our chapter 8. Now the next following questions that I will be doing are going to be from our previous chapters. We did skip chapter 7, so there's nothing on chapter 7. We didn't do chapter 7 in our class. But we will be working on questions from chapter 5 and chapter 6. So the first one we have is a simplifying. Simplifying, you're going to take this 2 and anything inside of that parentheses, including that 3, you're going to have an exponent. So 3 gets a bubble, put a 2 as an exponent, times. X squared gets its own bubble, put a 2 as an exponent, times. Y gets its own bubble, negative 3. With a 2 on top. Now, anything that has an exponent with an exponent, so not 3 squared that didn't have an exponent, 2 and 2 get multiplied. Negative 3 and 2 get multiplied. And now anything with the negative gets a reciprocal, it gets flipped. So what that means is that 3 squared is 9, 4 is positive as an exponent, 6 was negative, so 6 gets brought down on top of y. Okay. Now, the difference between what we just did and here is that we do have a denominator that is still inside that parentheses. So when we have that 3 and we place that 3 on everything, that literally means everything, including that denominator that we have. So when we write this out, write this a little higher, we will need a little space. We have 2 in parentheses with an exponent of 3 times x negative 2 to the power of 3 times y to the 4th to the power of 3 and x cubed to the power of 3. Every single thing gets that power of 3 because everything was in parentheses. Next, things that have an exponent with an exponent here get multiplied. Here we just have 2 to the power of 3. That means 2 times 2 times 2, which is 8. Here we are multiplying, so negative 2 times 3 is a negative 6. 4 times 3 is 12. 3 times 3 is 9. If you have anything that's negative as an exponent, that will be flipped. So if it's on the bottom, it goes on top. If it's on top, it goes on the bottom. The only thing we have that's negative is that x to the power of negative 6. Now you can do this 2 different ways. You can simplify first and then bring it, or you can change it. I'm going to actually notice that I have another x to the 9th on the bottom, so I'm going to choose to simplify that first before I deal with any negatives. Typically negatives you want to do at the end. So I'm going to separate this out. I do have my 8y to the 12th. It doesn't have anything like I don't have another y, I don't have another whole number, but I do have negative 6 and 9, both on x's. So to simplify that, we're going to take that negative 6 and we're going to say minus that 9. Okay, top minus bottom. Negative 6 minus 9, I get a negative 15. Now I want to handle my negatives by saying, okay, it's a negative exponent, and since it is a negative exponent, we're going to flip it and put it towards the bottom. So how will that look like as an answer? It will look like 8 times y to the power of 12 divided by x to the power of 15. Remember, once you flip it, you remove that negative. Next one we have is describe the transformation. Now this, I believe a similar question was on your chapter, I think it was chapter 6 exam. And I saw different questions, so I wanted to go through it. Since they are giving you this 3, you don't need to describe what happens to that 3. That 3 was in the parent function, so it doesn't change. What we are looking for is we're looking for our transformations of our a value, our h value, and our k value. Sometimes we do have a negative in front. This is not one of those cases. Since we see a fraction, this is going to be a vertical compression. It's less than 1, but greater than 0. It's not negative. By 1/2. Skip that 3. It's unimportant. Here we see a positive 1. That means we have a negative 1. And that means we go left by 1. Please do not say left by negative 1. Saying left is already identifying that it's negative. And then we see a negative 4. That means we have a negative 4. K is for keep, right? H is we change. So that means we go down. Again, not by negative 4. We just go down 4. Next 2 questions. This one is asking us to solve. We have a starting amount of $1,500. We have an interest rate of 4%. This keyword here, compounded, is very, very, very important. Okay, compounded tells you which formula to use. And the formula is the compounding formula, which requires an n value. This n value always follows the word compounding. So since we know we're going to be using the compounding formula, n tells you how frequently we are calculating in 1 year. Quarterly, a quarter is 4. So we have our formula. A is equal to P times 1 plus, this needs to be in parentheses, our rate divided by n, close it, caret, so this is our exponent, n times t. Your rate needs to be converted to a decimal. So we're going to shift 2 jumps to the right, so to the left, sorry, 0.04 is 4%. Time is years, this is our t value, and we're ready to write our equation. So A is equal to our starting amount, 1,500, times 1 plus, open your parentheses, our rate is 0.04, divided by n. Again, quarterly is our n, so this is 4. And we're going to raise that to the power of our n times our t, which is 2 years. Now, this is all going to be typed into the calculator exactly how you see it. Practice with me, please. 1,500 times, open, 1 plus, open, 0.04 divided by 4. Now be careful here. Close it. Then you're going to do a caret. Be careful here. You're going to open up parentheses. 4 times 2. Close it. Equals. Now because we are talking about money, we want to be careful how we're rounding. Money is 2 decimal places, but we want to always look at the next number. If this number is 5, 6, 7, 8, or 9, then we round up. So for us, we are going to round up. We get 1624.29. So that means we are going to have $1,624.29. This is a comma, not a decimal. Let's go again. How much interest will you earn in 8 years if you invest $7,500? Here's your rate, compounded semi-annually. Okay, so take a look. We have the word compounded. That means we're going to use the compounding formula. Compounded formula means that the next word you have is your end value. Semi-annually means twice a year. Okay, so let's go ahead and start. We have our formula. I'm not going to write out our formula. I'm just going to start plugging in information. We have $7,500 that we are investing. Our rate does need to be converted to a decimal. Now, even though you see a decimal, it's still a percentage. We do need to shift it over 2 jumps to the left. So we have 0.045 as our rate. Make sure you have double parentheses here. Semi-annually means 2. Then we have double parentheses, caret. Then we will have our compounded, which is 2 times 8, because 8 years. And we have, type it in, exactly what we see, 7500, open 1 plus, open 0.045, divided by 2, close it, caret, open 2 times 8. And again, careful how you're doing it. People are very, very mindful about their money. Since we have 2 decimal places, the next number is 0. We're going to round it to 16 cents. So this is $10,707.16. All right, moving on. And that's it. All right. That's just an extra copy that I made for myself. Thank you so much for watching this video, and I will see you in the next one. Bye.